Students, welcome to the science class. In last session, we discussed about the representation of the motion in terms of the graphs, that is by velocity time graphs and distance time graphs, isn't it? And also in last class, we discussed about some of the expressions by using velocity time graphs and distance time graphs. Recall that expressions, that is one is V is equal to u plus at, and another one is v square minus u square is equal to 2as, and another one expression is s is equal to ut plus half at square, ut plus half at square, isn't it? These three expressions where we are derived in last session by using velocity time graphs. In today's session, we are going to discuss some of the problems on that. Now consider one problem. A train is traveling. A train is traveling. A train is traveling at a speed of 90 km per hour. At a speed of 90 km per hour. Brakes are applied. Brakes are applied. Brakes are applied so as to produce brakes are applied so as to produce a uniform acceleration of uniform acceleration of 0.5 meter per second square. Find how far the train will go. Find how far the train will go. The train will go before it is brought to rest. Before it is brought to rest. Solution. See here, students, once again you have to read the given problem. A train is traveling at a speed of 90 km per hour. It is traveling at a speed of 90 km per hour. That is, presently it is traveling at a speed of 90 km per hour. Brakes are applied so as to produce uniform acceleration of 0.5 meter per second square. Suddenly a brake is applied to a moving train of 90 km per hour. How it is brake applied in such a condition that it should be moved with a 0.5 meter per second square acceleration. Find how far the train will go before it is brought to rest. So when you are going to apply the brake of when it is going about 90 km per hour, after applying the brake, how much distance it covers to stop the train, that we are going to calculate here. That is nothing but s. So write down here what they are given. See what they are given. We are going to use here the brake we are going to apply when the train will be moving at the speed of 90 km per hour. Therefore, given, write down given data here. Given initial velocity of the train. Initial velocity of the train u is equal to, now I am taking the initial velocity of the train as a 90 km per hour, because after 90 km per hour we are going to apply the brakes. So here the initial velocity is 90 km per hour. So the given data is in terms of kilometer per hour. We have to convert it into meter per second by multiplying 10 by 36. We get, by multiplying 10 by 36 we get in meter per second. See here, 6 6 are 6 15s are, then 3 2s are 3 5s are, 2 1s are 2 5s are, that is equal to 5, that is equal to here 5 into 5, 5 into 5, that is equal to 25 meter per second initial velocity. U is equal to what we get, 25 meter per second. And then the final velocity of the train V is equal to, the final velocity of the train V is equal to 0 here, because after the train, when the after applying the brake, the train will be moves with the acceleration of 0.5 meter per second square. After some times it's going to be at rest. So the final velocity of the train is V is equal to 0. Then the given here, the acceleration of the train, they are given acceleration of the train A is equal to how much, 0.5 meter per second square. Okay, and then what they are asked, and also we have to find here, to find out the distance traveled, we have to find time t is equal to what, and also distance s is equal to what, distance s is equal to what. So we know that an expression, final velocity v is equal to u plus at. Because why I am taking this expression here, because first we have to find out the time t. So time t is present in the expression v is equal to u plus at. And also why I am taking this expression here, because we know only initial velocity and the final velocity and acceleration. That is, we know here final velocity, initial velocity and acceleration, these three are known. So that's why I am taking this expression to find out the t, time t equal to what. So now see here, it implies us this at is equal to this u comes this side, that is v minus u, that it implies us we have to find out a t here. Therefore t is equal to v minus u, this a will be comes here divided by a. So now we have to put the values. T is equal to, what is the value of p here, 0 minus u, what is the value of u, 25 meter per second divided by, what is the value of a, 0.5 divided, that is equal to minus 25 divided by, I am going to take here that 0.5 as 5 into 10 raised to minus 1. 0.5 can be written as 5 into 10 raised to minus 1, because it is in terms, we can write it as a 5 into 10 raised to minus 1, that is nothing but 0.5. So here 5 ones are 5 5s are, and that is equal to minus 5 divided by 1 into 10 raised to minus 1. So now take 10 raised to minus 1 into the numerator, it becomes plus 10 raised to plus 1, that is equal to minus 5 into 10 raised to 1. Therefore time t is equal to what we get here, minus 5 into 10 raised to 1, that is equal to t is equal to 50 seconds. That is, we get a minus 50 seconds, but we have to take it as a positive, because time is always in a positive. So t is equal to minus 50 seconds we get now. So what they are asked, actually they asked the distance travelled by the train after applying the brake, that is s is equal to what. So now we have to find out by the expression, we know that, but we know that s is equal to, see, I am taking this expression here, v square minus u square is equal to 2as. It implies us 2as is equal to 2 2as is equal to v square minus u square, and it implies s is equal to v square minus u square divided by 2a. Now you have to put the values of v, u and a here. You have already know v, u and a. So s is equal to v square. What is the value of v here? Value of v is 0, that is 0 square minus u, that value of u is 25. 25 it's a square divided by the 2 into 0.5. That is equal to s is equal to 0 square, it is 0 minus 25 is a square, that is 625 divided by 2 into, again I am right here, I will try to write here 0.5 as a 5 into 10 raised to minus 1. So divided 5 ones are 5, 125 are 5 ones are 5, 125 are, and again see here this 2 will be comes at the again by divided 2 ones are see 262 are, that is 124, remaining one 2 5 are, that is equal to 62.5 into 10 raised to 1, because 10 raised to minus 1 comes at the this 62.5 into 10 raised to minus 1, here 2 into 10 raised to minus 1, we are going to take it as a numerator as a 10 raised to plus 1. Therefore it implies s is equal to what we get 62.5 into 10 raised to 1, that is s is equal to 625 meter. 625 meter. So what is the answer here? After applying the brake to a train which the train where travels in the speed of 90 km per hour, when we are going to apply the brake, it may take to rest after that, it may take rest after the 50 seconds, minus 50 seconds after traveling the distance of 625 meter. So remember, when the train driver going to, if the train driver going to stop the train, then he want to apply the brake before 625 meter. If the train will be moves with the speed of 90 km per hour, if the train will be moves with the speed of 90 km per hour, if a train pilot can going to stop the train, if he decided to stop the train, then he may apply the brake before 625 meter. I got understood. So what they ask actually here is the train, find how far the train will be before it's brought to rest. Find how far the train will go before it is brought to rest. So the train will be goes about 625 meter before it goes to rest. So I am considering another one example here. See another one example. Sorry, write again the expressions. V is equal to u plus at, v square minus u square is equal to 2as, and s is equal to ut plus half at square. These are the required expressions to solve the problems. So second example here. A car accelerates uniformly a car accelerates uniformly from 18 kilometer per hour to 36 kilometer per hour in a 5 seconds. In 5 seconds. Calculate one here is acceleration of the car. Second one is distance covered by the car in that time. Second one, distance covered by the car in that time. See, once again you have to read the given problem. A car accelerates uniformly from 18 km per hour to 36 km per hour. That means the initial velocity of the car here is 18 km per hour and the final velocity of the car here is 36 km per hour. What it means, a car accelerates uniformly from 18 km per hour to 36 km per hour. It changes the initial velocity. It changes its accelerations from 18 km per hour to 36 km per hour. So here the initial velocity is 18 km per hour and final velocity is 36 km per hour in a time 5 seconds. In time 5 seconds. What we are going to calculate here? Calculate one acceleration is equal to what and distance covered by the car is what. So see here solution. Write down the given data. Given initial velocity of the car u is equal to 18 km per hour and you have to convert this in terms of meter per second by multiplying 10 divided by 36. 18 ones are 18 twos are 2 ones are 2 fives are, that is equal to 5 meter per second. It is the initial velocity and final velocity is equal to that is equal to v is equal to the final velocity is here 36 km per hour. You have to convert it in terms of meter per second. V is equal to 36 into 10 divided by 36. This 36 get cancelled, that is equal to 10 meter per second. We get here u is equal to 5 meter per second, v is equal to 10 meter per second. Write down here u is equal to 5 meter per second, v is equal to 10 meter per second, and what is the time here? 5 seconds. Isn't it? They are given time here 5 seconds. What they are asked? Acceleration. Therefore first one, acceleration of the car. Acceleration of the car a is equal to what? We know that v is equal to u plus at. It implies at is equal to v minus u. It implies a is equal to v minus u divided by t. That is equal to, substitute the values. V is equal to 10 here, 10 minus u is equal to 5 divided by time t is equal to 5. That implies 10 minus 5 is equal to 5 divided by 5. 5 ones are 5 ones are. Therefore a is equal to 1 meter per second square. 1 meter per second square. That is the acceleration of the car. Then what they are asked for? Second thing, the distance covered by the car. Distance covered by the car. S is equal to distance covered by the car. S is equal to, you may take any one expression here. Either you will take v square minus u square is equal to 2as, or you take s is equal to ut plus half at square. So see here, I am taking s is equal to ut plus half at square. That is equal to, the value of u is 5, and the value of t is t 5, and also 1 divided by the acceleration value is 1 meter per second square, and t square, that is 5 square, that is equal to 5 into 5 here 25 plus 1 divided by 2 into 5 square is 25, that is equal to 2 ones are 2 12.24 12.5 that is 25 plus 12.5, that is s is equal to s, how much the distance here, that is 37.5 meters. The total distance covered by the total distance covered by the car is 37.5 meter. It is the total distance covered by the car in a given time 5 seconds. Have you got understood? So these type of the examples may ask in your examination for 2 or 3 marks question. You have to practice these examples in your home. Now I am taking another one example on this. Another one example. The brakes applied, third one, the brakes applied to a car, produced an acceleration of 6 meter per second square in the opposite direction, opposite direction to the motion. If the car takes 2 seconds to stop, if car takes 2 seconds to stop, if the car takes 2 seconds to stop after the application of the brake, after the application of brake, calculate the distance it travels during this time. Calculate the distance it travels during this time. Okay, once again you have to read the given example. The brakes applied to a car produced an acceleration of 6 meter per second square. The brakes applied to a car produced an acceleration of 6 meter per second square in the opposite direction to the motion. See, listen here. Imagine that a car is moving. Suddenly brake is applied. Have you got understood? The acceleration produced due to the application of brake in the opposite direction. The acceleration, not the acceleration comes in the direction of the motion, but it comes opposite direction of the motion. So see here, the brakes applied to a car produced an acceleration of 6 meter per second square in the opposite direction to the motion. If car takes 2 seconds to stop, if after the application of the brake the car takes 2 seconds to stop, The car takes 2 seconds to stop after the application of the brake. Calculate the distance it travel during this time. So when the after the application of the brake, the car has the opposite acceleration of 6 meter per second square. So in that 6 meter per acceleration of that 6 meter per second square, how much distance it covers in a given 2 seconds? That's why I am going to calculate here. So given, write down solution. Given, write down the given data here. Given acceleration A is equal to, I am taking here minus 6 meter per second square. Then the question arises in your mind, why I take the acceleration as a negative? Because the acceleration produced due to the application of the brake in the opposite direction. Imagine that car is moving in this direction, but after application of the brake, the acceleration will be comes under this side direction, opposite to the motion of the car. Therefore, I am taking acceleration here in the negative, in terms of negative. That is, acceleration A is equal to minus 6 meter per second square, and the final velocity will be 0 here. Why? Because the car comes at rest after application of the brake. Final velocity V is equal to 0, and the initial velocity, we have to find out initial velocity is equal to what? Initial velocity is U is equal to what? And they give the time. In the time T is equal to 2 seconds. Okay, we have to calculate here initial velocity U is equal to what? After onwards we are going to calculate the how much distance it travels after the applying the brake in 2 seconds. Okay, first we have to calculate U here, and also without calculating the U, it is not easy to calculate the total distance. So we have to calculate here initial velocity. We know that V is equal to U plus AT. It implies U is equal to, that we have to calculate here initial velocity. We required here initial velocity. That's why I am keeping the U as it is. I am transferring AT to this side. U is equal to V minus AT. U is equal to, that implies U is equal to, the value of V here is 0 minus A is minus 6 meter per second square into T is 2. That is, U is equal to minus of minus 12. That is equal, U is equal to 12 meter per second. We get the value of initial velocity here, that is U is equal to 12 meter per second. Then now we are going to calculate the distance travelled by the car after application of the brake with the acceleration of 6 meter per second square in the opposite direction of the motion of the car in 2 seconds. It is what? That is the distance travelled by the car. Distance travelled by the car. S is equal to, either you may use V square minus U square is equal to 2S, or S is equal to UT plus half AT square. Again I am taking here S is equal to UT. So I am taking here V square minus U square is equal to 2AS. We know that V square minus U square is equal to 2AS. We have to find out S here. So keep the S here only, transfer 2A to this side. Therefore S is equal to V square minus U square divided by 2A. Substitute the value here. S is equal to, it implies the value of E here is 0. S is equal to 0 square minus V square minus U square. The value of V is 0 and the value of U is 12. That is 12 square divided by 2 into the value of A is 6 meter per second square. That is minus 6. I am taking minus 6 here. S is equal to 0 square is 0, 0 minus 12 square is 144, isn't it? 2 into minus 6 is minus 12. That is equal to minus 144 divided by minus 12. 12 ones are 12 12s are. This 12 get cancelled. That is S is equal to 12 meter. The distance travelled by the car in that given time after the application of the brake is 12 meter. Therefore, write down here, car travels 12 meter after application of the brake. So, see here, when a moving car applies the brake, after application of the brake, the car will becomes at rest after 2 seconds. About it travels the 12 meter. You have to remember, in the back side of the vehicle, they are see the back side of the vehicles like lorries. They are write some words in that the back side, that is keep distance. Why they are going to write down as a keep distance? Because when they are going to apply the brake, so the vehicle will be moved 12 meter backwards. Have you got understood? So when you are going to travel anywhere, or when you are going to drive your bikes, or when you are in the bike, so you have to keep distance from the other vehicle about more than 12 to 20 meters, because when they are apply the brake, it may takes to rest after 12 meter by traveling about 12 meter. In that cases, if you are not maintaining that distances, in the case there is a chance to happen an accident. So to avoid the accident, you have to keep the distance from the vehicle. So once again I am explaining here. Here they give the, imagine a car will be moves with the acceleration of it moves with the initial velocity of 12 meter per second, and finally it is after the application of the brakes it comes to the rest. So we have to calculate what is the distance travelled by the car after application of the brakes. After application of the brake, car travels about 12 meter. So I am considering another one example on this here. Fourth one, a bus starting from a rest. A bus starting from a rest. A bus starting from a rest moves with the uniform acceleration moves with uniform acceleration of 0.1 meter per second square for 2 minutes. For 2 minutes. Find A, the speed acquired and B, the distance travelled. See, once again you have to read the given problem. A bus is starting from a rest moves with a uniform acceleration of 0.1 meter per second square. A bus is already traveling in the some speed. I got understood. With the acceleration of 0.1 meter per second square, it has the uniform acceleration of 0.1 meter per second square. They are clearly give here a bus is starting from a rest. From a rest means the initial velocity of the bus here is u is equal to 0. Moves with the uniform acceleration, that is the bus after it moves with the uniform acceleration of 0.1 meter per second square, and in a 2 minutes find the speed of acquired. So we have to find the speed acquired after the given time 2 minutes. After 2 minutes, how much the bus will be goes with how much speed we have to find here, that is the final velocity v is equal to what, and also the distance traveled s is equal to what. Solution: write down the given data here. Given in here final velocity we have to find out. The given here is initial velocity. A car moving from the a bus starts from a rest position, so the initial velocity is 0 here, and it's have an acceleration of the bus a is equal to, that is 0.1 meter per second square. It moves with the acceleration of 0.1 meter per second square in a time t is equal to given 2 minutes. So again here, see here, we should convert the minutes in terms of seconds. T is equal to 2 into 60, because for 1 minute we have a 60 seconds, therefore T is equal to 120 seconds. So what we are calculate here, what we should calculate here, the final velocity, the speed acquired by the bus. The speed acquired by the bus. V is equal to u plus at. V is equal to value of u is 0 here, plus a is 0.1 into the time is 120 seconds. Therefore V is equal to 0, get cancel, that is 0.1. I can write it as 0.1 here. 1 into 10 raised to minus 1 into 120, that is V is equal to, see, 120 into 10 raised to minus 1. V is equal to, so 10 raised to minus 1. So we have to shift the point from this point to this point here, that is equal to 12.0 meter per second. That is V is equal to 12 meter per second. We have to write it as a 12.0 because we shift the point, the decimal to here, because we have here 10 raised to minus 1. 10 raised to minus 1 is nothing but 0.1. Why? Because 0.1 can be written as, so we have to shift the decimal to here. Have you got understood? So we have to shift here. So therefore I can 1 into 10 raised to, so we have to shift for it is converted to 1, that is into 10 raised to minus 1. 1 into 10 raised to minus 1, it is nothing but 0.1. I am replacing 0.1 here by 10 raised to minus 1, that is V is equal to 12 meter per second. It is the final velocity of the bus. And also they ask second, total distance S is equal to total distance traveled by the bus, that is S is equal to, again you take any one formula, ut plus half at square, or S is equal to V square minus U square divided by 2a. I am taking V square minus U square divided by 2a here, that is equal to V square, the final velocity is 12 is square minus initially 0 divided by the 2 into acceleration is given here, that is 0.1, 2 into 0.1. Consider here S is equal to the 12 square, that is equal to 144 minus 0 divided by 2 into, again I will write it as a 1 into 10 raised to minus 1. 0.1 will be replaced by 1 into 10 raised to minus 1. So therefore 2 ones are 2, here 62s are, isn't it? Sorry, 72s are. That is equal to 72 into 10 raised to minus 1. Here is that you have to take it to the numerator, into 10 raised to 1. That is equal to S is equal to 72 into 10 is 720 meter. The bus travels about 720 meter in the given time 2 minutes with the acceleration of 0.1 meter per second square. These type of the problems may ask to in your examination for 2 to 3 marks question or a 4 marks question. So you have to concentrate on these problems and you have to practice more on these problems. They are very simple. You have to remember these 3 expressions. Have got understood. By using these three expressions, we are going to calculate easily the asked data. So that the expressions are V is equal to U plus AT, that is initial velocity V is equal to, final velocity V is equal to initial velocity plus acceleration into given time, and V square is minus U square is equal to 2AS, and S is equal to UT plus half AT square. These 3 are the very important equations to calculate the given problems. So in today's lesson, students, we studied some more problems on the given expressions, that is V is equal to U plus AT, V square minus U square is equal to 2AS, and S is equal to UT plus half AT square. These are the very important examples that may come to your examination. So, and this completes your lesson, the very important lesson in your 9th standard, that is motion. You have to practice some of the examples given in your textbook as a text questions and also exercise questions. So we can see in the next class. Thank you, students.